1 year ago, we started using React Compiler in production, and we joined the working group at Sanity. Sanity is a content operating system. It's used to drive how Riot Games pushes out lore in their games. AT&T uses us to push out new phones after Apple events. RBI uses us to push out burgers. You get the idea. There's a wide spectrum of the way businesses run their content ops. And there's a lot of React apps involved when pushing out all of this content. And the most important one we have is Sanity Studio, which started as a CMS. It has since then grown into becoming a React framework built on top of Vite, as our philosophy is that your content creation should adapt to your business and not the other way around. We also don't have the luxury of having a save button. So if you have your CMS today that has a save button, maybe you should consider upgrading. Now, the studio itself is not a new code base. It's the brownest of brownfields. It started out when we were using React 15, and even used flow type at some point. And even though we have been performance focused from the start, come 2024, we started to feel like we were hitting the wall. We had to send a PR to increase the payload so we could even look at the perf traces and all the data when looking into large studios. And then when we could look at the charts, there was just way too much data to look at. It felt pretty much like dying to like a death to 1,000 cuts, tiny little re-renders. So I'm Cody. I'm supposed to be in sunny Greece right now on the Sanity all staff, all hands. But I'm here. I'm excited to tell you our story. And I can see why you like having React Conf here. It's beautiful in Lake Las Vegas. So 2024, on this stage, React Compiler got introduced, and it seemed like it could be the solution to the problems we were seeing. We got very excited. At the same time, there is no free lunch. There's always a catch. And the catch that we saw the React Compiler had was that you needed to have code that was correct, that followed the rules of React, so it has to be pure, and follow all of these principles. And if you think about it, those are the same principles you should have if you don't want bugs in your app. So even though the compiler was experimental, we decided, let's use the linter everywhere right off the bat and see what kind of bugs it can detect with its advanced new static analysis. And then, stage 2, let's figure out how to use it in production and memoize our code, and of course then profit. And on our first trial run on the studio code base, on one hand, it's great to see over 1,000 components memoized, but still, there's like hundreds of components that were not memoized. And the linter told us why. We started looking at them. And it was just really effective in finding bugs that we knew were hiding there somewhere, but we weren't able to find the cause. One of them is in our rich text editor. So we had known for quite some time that for some reason in strict mode, it was suspiciously slow. We couldn't really figure out why, but now with the linter calling out that you can't disable this ESLint check, just want to check, this is a safe space, but everyone that has written this comment that says ESLint disable next line React hooks, exhaustive depths, I want you to raise your hand. You don't have to look around, just raise your hand. All right, there's 2 types of React developers. First one is you have done this. The second one is you're a filthy liar. So that's just how it is. And strict mode seeing a problem here is no longer like this is no longer a strict mode problem. It's also a problem when you use the new activity component, because you don't really want, like in this case, the sync range declarations to happen just because the visibility is hidden, right? So the fix, run it on a condition, do it during render, and now that's solved. And these are kind of fixes that we started rolling out before we actually shipped pre-compiled code on NPM and started letting our customers use it. But again, everything has a catch, right? And the catch the compiler has is that your code needs to follow the rules of React and be resilient. That's a good catch to have compared to other solutions we had before. So that's a thing you will realize when you use the compiler. We were expecting to find bugs since it was experimental, but the bugs were ours all along, and we had quite a lot to fix. On top of that, since Sanity is used on a whole lot of different frameworks in different ways, because we're not just talking about the studio, but also how you render your application, shipping React compiler code on all of these different platforms required some research as well. Just one thing to know about. If you're shipping something that is supposed to be a server component, in server components, then you need to have 2 exports of that library, because you cannot use React compiler on code that is being server rendered, which makes sense because a server component doesn't have state, it doesn't re-render. Why would you memoize it? So that's just one of those things we had to figure out. But it worked out really well for us. As of today, we've been using it on NPM, or on our NPM libraries for almost a year. And what's really great about when you publish code on NPM that is optimized by the compiler, there's no changes to your consumers. You just push the code out. Your customers will update the version, and it's just faster. There's nothing to do on their end. Of course, on our Studio or React framework, we also allow you to use the compiler on your custom React components and hooks. And we, of course, also use Next.js on our applications around in our org, and we use the compiler there too. We also have a success story where we launched a brand new product on top of the experimental React, so we could use activity to keep iframes alive instead of destroying them and then having to load the iframe as you switch between apps. And with the compiler, and which was very risky, but it worked really well. It's surprising how something that is called experimental can be quite stable. So after doing all of that, I want to share my 3 favorite unexpected lessons coming out of it. The first one is that there's a lot more to auto-memoization than you think of initially. Because when you think about no longer having to write a use memo hook, it makes you think about the times you wrote those hooks. But that severely undercuts the value of the compiler, because it writes memoization that a human should absolutely never do or couldn't do. So here's a simplified version of our studio provider. It's way more nested than this. There's not enough screen space to show that. And when the compiler is run on it, you can see how it's very granular. So there are auth boundaries, studio theme provider, workspaces provider, color scheme provider. It's doing a really good job of being extremely granular. So if you were to do that manually, it would look something like this. But if someone sends you a PR and they've done this, you need to ask, are you okay? Do you need a break? Because a human should never write this, even though it would give you similar performance benefits, because you also lose the ability to actually see what the tree structure is anymore, right? Like T4, T3, no idea how it's composed anymore. It's just all flattened. And then my favorite thing, it can memoize stuff that you cannot, for real. So if you look here at the merge theme call, it happens after a return. Now, if you know the rules of React, you're not allowed to put a use memo there. You can't. So you would have to change your component. The compiler, it doesn't care. It can do that. It will just memoize what happens if you do have children. And when you combine it with the use hook on a context, you get this really powerful benefit of conditionally subscribing to a context. And then those branches are also memoized. I want you to think about all of those code paths you have where you could leverage this conditional nature of context subscriptions, which is great for performance, and pair it with the compiler with that, where that is also memoized. Now the second one is, I thought I knew React. And now I'm humbled, so I know that there's a lot of stuff that I had to learn and still need to learn. And that's an effect we saw internally as well. With this new powerful diagnostics that is able to detect things that would just fly under the radar on PRs, it's a lot of stuff to learn. And I'm going to show one of those. A lot of us have done this. In our case, we have public APIs where we expose hooks and components where we don't control how our customers write them. So sometimes they provide unstable values that have negative consequences, like maybe it will trigger a resubscription if a dependency change. We don't want that, so this hook tries to solve it. And now the diagnostics you see here is, if you like Rust, you'll recognize like how friendly and educational it is, and then it points to documentation. Now, if you follow that documentation and you land on a page called "You might not need an effect," if you haven't read it, you should absolutely read it. It's very good. Yes, and it points to solutions like this. So you see the solution is that we should have just have it in state, and then we can compare it during render. And on line 11, there's like an extra little perf trick where we return the new value right away instead of waiting for the next render to do it, which helps with the memoization as well. So, third step. You might have thought that you could blame React for a lot of problems in your application. Turns out it might not be. In our case, after the compiler was enabled, the style component related components were very overrepresented in the flame chart. So we had to dig in and figure out why. And long story short, there is a new hook that came in React 18 called use insertion effect. Great name that Rick named it. It's a good name. And style components is not using it. And here we build a little benchmark that will show you what happens when you don't use the hook. So what you're looking at now is the baseline. Tries to render all the tiles in React transition. There's a little radar in the top left corner that Dan used when he talked about time slicing like years ago. And everything is fine. Now, in our fork of style components, we use the new hook. And when we trigger the condition that is not ideal when you have concurrent render, you see the letters are shaking a little bit, but it's still able to actually finish most of the tiles. So it's not ideal, but it's still fine. Now, check this out. It just stops. And then the deadline hits, and it's like, oh, render everything synchronously, causing jank, really, really bad. So the reason I'm highlighting this is just to give you an idea of the kind of perf work or time that you can spend on solving much more interesting issues and much more impactful issues when you no longer have to spend so much time either debugging things that could have been caught by the new linter or manually memoizing things. So, how to adopt the React compiler from the perspective of someone that is new to perf work. You haven't spent a lot of time doing that. First step is you need to think about where you need it the most, of course. The compiler doesn't speed up like initial render. It's about re-renders. So you can think about maybe data tables or charts or things where a lot of stuff is happening and you have a lot of re-renders. And when you have that, my favorite thing to do is to enable the FPS meter in Chrome, and then in React DevTools you can turn on highlights on the re-renders, which gives you an idea of what is happening. And as you can see in this application, there's a suspicious amount of re-renders, because ideally it should only re-render when I hit fetch, right? But it's just re-rendering all the time and a bunch of components. And as you can see, this is before we got rid of style components, which is also not great. Then, if you haven't enabled the linter already, you should definitely do it to get an idea as a pre-flight check of what will happen when you enable it. If the linter is just like all good, nothing to see here, then you should get really good results, right? But if there are some issues, then whatever that issue is, because usually the compiler will just not optimize something if there is an issue. But then, if it does that, you might not get the perf results that you're expecting, but the linter gives an idea why. Maybe the component it's skipping over is on a hot path, and then it's like, oh, well, of course, it's almost no benefit, right? So then you set up the compiler. There's a lot of different ways of doing it, depending on what framework you use, of course. But then let's measure the gains. Let's go back and see what happens. So with the FPS counter, we can see there's better FPS. And now when you hit fetch, it re-renders. You don't hit fetch, nothing happens. That's the way it should be. And then you also see these amazing little memo badges with the cool little sparkle, which tells you that this component is memoized, which also helps if something is slow. If it doesn't have the badge, then it's not being memoized by the compiler, right? Now, at Sanity, we've been in this performance game for quite some time. We have this thing called the EFPS suite, which it's like, it measures editing frames per second. Oh dear. Why is Discord here? There we go. And what it does, it measures the frame rate per second when you're doing editing activities like a rich text field or inputs, the kind of stuff that content creators does. And the point is that it should be as high as possible, and it runs on PRs. So when we enabled the React compiler, we saw that it gave us a 20 to 30% boost. And these are like worst case scenarios on average. So that's very good. We have customers telling us that they see much better results than what we've been measuring. And yes, that's great. And this happens multiple times. Like in our case, we don't have full coverage. But as we see, we get more and more coverage. We see this happening again. So recently, we got our design system 100% compiled, and we saw again a 20 to 30% boost just by reaching 100%. So even though it takes time, you get like a gradual improvement as you work through issues, which also fixes bugs. So it's interesting to think about how this has affected how we write code in AI, of course. So in the before times, without the analysis, you want to be in the make it work step where you're having fun, you're in the zone, it's a very short feedback loop, and you have everything you need to build your feature. But maybe you fucked it up on one of those rules, and now you have to come back to make it right when Sentry tells you that there's a bug. And now that's also very slow, because without the static analysis, you have to put console logs, debugger calls everywhere. It's not fun. And likewise with make it fast, someone complains it's not fast enough, you have to go back in, why isn't it fast enough? And you have to do manual memoization, and it sucks. Now with the new flow, you spend a whole lot more time in make it work. And while there's still a make it right flow, that's integrated in the make it work step, since you have the new intervals that are right there in your IDE while you work. And over time, as you learn React fundamentals and fix issues, you get the bubble that says make it work just continues to grow, and the make it right just shrinks, which is awesome. So in addition to being a tool that makes your application faster, we see that the surprise benefits is that you will find bugs you didn't know existed, or maybe you did know it existed, but you couldn't find it. You will be able to learn React fundamentals that will help you fully leverage new features. Activity is one of them, but there's more underway. And you will be able to find dependency bottlenecks. In our case, we had style components. There's more. And you don't have to pay Claude for writing shitty code anymore, which is also really good. So should you use it? Absolutely. Why aren't you already? Go use it. Thank you.